Good morning. My name is Ernest Stambouli, and I welcome you all to the webinar. This is Configuration Management for the Multi-Team and Multi-Stakeholder MBSE Enterprise. I am the founder of Achilles Inc. We are a small business located in Southern California, a consultancy focusing on model-based and model-driven development approaches, serving the enterprise business and systems engineering communities in many industries. I've been in the field for 25 years, and I am the author and the publisher of many books on the subject. With me is Daniel Siegl with LieberLieber. LieberLieber is a software development company founded in 1996, and they have a global presence in the model-based engineering world. Daniel is the business development person for LieberLieber. He is also technical savvy. I've known him for over 15 years, and we have a long trusted relationship. So I asked Daniel to attend as a panelist today so he can support me in this webinar with the tough questions about their widely popular tool, LemonTree, which is a required tool for what we will be covering this hour. LemonTree is a visual diff and merge tool for models. And so you'll also get to see a demonstration of it towards the end of the webinar, if time allows. Good morning, Daniel.
Good morning, Ernest. Good morning, everyone.
Thank you for joining us here. This is the second webinar in a series of 3 webinars. For those of you who have missed the first webinar, which was on version control, you can find it on YouTube. Just get on there, search for MBSE model version control best practices, or here is that cryptic URL from YouTube if you'd like to take note of it. Here is the outline of the webinar today. First, we will take a look at configuration management, its barriers in traditional systems engineering and conventional development environments. And then we're going to look at the state of the practice, what makes configuration management fully feasible with model-based systems engineering, and what are the competing strategies for approaching a solid configuration management solution for your MBSE environment. If you are on this webinar, I am moving with the assumption that you already have a background in model-based engineering and you're familiar with some modeling tool. The modeling tool that we use usually here is Enterprise Architect and from Spark Systems, and that's the tool that works with LemonTree. I am going to take a strategic approach today talking about configuration management in model-based engineering. So we're not going to get too technical here. We're going to keep it high level so I can show you the lay of the land as far as configuration management for model-based engineering is concerned, but mostly to approach it from the wider context, which is product family engineering or product line engineering, which is really our ultimate aim in this webinar series. Now, if you've ever looked at tackling product family engineering in your environment, you probably already have a sense of the extraordinary complexity of this task. One of the challenges is identifying the right tools, the methodology that works, the languages to use. And here we're talking about formal languages like UML and SysML and SOAML, and there are many others. And of course, architecture. And by architecture, I don't mean the architecture of the system under development. I mean enterprise architecture, those rules and principles that govern the entire development process. So the challenge of product family engineering requires a strategy for specifying, maintaining, and deploying product variants across varied markets from single base specs and reusable artifacts. This is a 3-webinar series, as I mentioned earlier. And in this series, you will learn how to incrementally approach product family engineering from within your standard MBSE environment. Right? So what tools will be needed, what architectural concerns must be addressed upfront, and how to take advantage of existing standard modeling languages such as SysML and UML and so on. So first, let's start with some definitions or descriptions of what configuration management is, but more specifically how it applies to a model-based environment. Configuration management is a management practice that manages the definition of a product, of a system, or a process from its earlier definition all the way through the life cycle of the product. And CM is the context for accurately and unambiguously assembling the correct versions of artifacts to fulfill a client's request with a consistent configuration of related resources. The way you implement configuration management has special implications for product family engineering because it requires a strategic focus upfront to alleviate this complexity that comes with product family engineering. So to specify, maintain, and deploy product variants across varied markets from a single base specs and reusable artifacts. There are a set of limitations and barriers that apply to traditional systems engineering or enterprise product development because the traditional way of building products relies on text documentation, on artifacts of various sorts that are all maintained by systems developers and engineers and updated as requirements change. Most of you would be familiar with that change cycle. So this is an issue that has emerged as the problem of managing multiple versions of complex systems using traditional systems engineering techniques. There was a study in 2014 that found 19 barriers to the successful implementation of configuration management. And the study was done in private aerospace as opposed to defense aerospace. And those barriers prevent the process from achieving the desired goals of controlling product definitions and recording the changes, and doing all that from a single base set of artifacts, and in our case, a single base model. Model-based engineering, systems engineering, solves these issues that we found with traditional enterprise product development. And it actually eliminates the barriers that were found because it does not rely on documents, as you would know. When we have a document-centric approach, the content of the documents is not easily referenceable. That's one of the fundamental difference between a model-based approach and a document-based approach. But when you rely on models that are properly organized as unambiguously referenceable elements across many levels of abstraction, then those barriers disappear. Today, we see a few approaches to configuration management in model-based environments, and that is establishing product configuration metadata against a model, right? The model of a system. But we need to really go beyond the notion that a configuration metadata, because our aim is to establish a product family engineering enabled platform that is based on a formally defined configuration management mechanism. And that last bit is what this webinar is about. We are going to look at a sample project to explain the different schemes that are being used in many industries. So here the example is called UWEYS Sonars. This is borrowed from a real project that we led more than a decade ago. And the names have been changed to maintain confidentiality, of course. That company offers a sonar product line for deep water reconnaissance. It was initially conceived for a single application. It was a small company that grew very rapidly because they were able to move into different markets. So UWEYS Sonars wanted to leverage their existing product assets at many levels to produce product variants serving new application areas without reinvention and without replicating entire product specs and artifacts. Their business objective was to provide a sonar product line that is marketed and sold in many application areas. And as you can see on this slide, the application areas range from seabed mapping for port and harbor operations, mine countermeasures in marine obstacle avoidance, offshore oil and gas, seismic deep water reconnaissance, and wildfire research and marine archaeology. Their strategic objectives were to manufacture a core set of underwater sensors with related devices and instruments, along with control and management software. So their strategic objectives is to assemble and configure core devices and instruments in a multitude of variants so that they can support the different application domains for their customers. Another objective is to utilize multiple suppliers of mechanical and electronic parts. And finally, the last objective is to develop its application software internally, but rely on off-the-shelf components for standard capabilities such as data compression, communication, and so on. The challenges that they ran into is that the current production methodology was inadequate for developing and maintaining different product variants for targeted application domains. The current development process was inadequate for managing different client requirements across the application domains, and they didn't have the know-how and methods for managing the evolution of each particular product. So they were facing a set of threats with their current production approach and their current procurement and their current development processes. And the threats range from proliferation of product copies across application domains. And this is something that I would guess that many of you would have seen if you're dealing with multiple product lines or even just multiple customers with their own specific requirements within the same application domain. The threat was also the proliferation of product copies across clients with application domains, and they ended up with a combinatorial increase of costs of change propagation across copies and their variants. It's one thing to maintain one set of models and the resulting code and all of the different specs for the hardware parts, but when you have all of those replicated for different objectives, then you get into what's known as thrashing. For those of you who remember your operating system course, thrashing is when you spend more time managing something than actually doing work. So they ended up consuming more engineering and development resources and time for maintaining configurations and variants than for developing and enhancing their systems. So here we have a package diagram for those of you who read UML or SysML, and this is by no means a complete diagram of the system. This is just offered for illustration. We have a set of applications that focus on the dry end and the wet end of the sonar system, and those depend on a package that holds all of the infrastructural code and components, which includes set of services for data processing, I/O processing, and so on. And we have a set of interfaces for both parts of the sonar system, the dry end and the wet end, to interface and interoperate. When we started the conversation with them about the variability requirements and the challenges that they're looking at, their requirements was that the wet-dry interface, they wanted it to accommodate different combinations of transmission and receiver arrays for the sonar system. They wanted to be able to accommodate different combinations of protocols, and they wanted a variety of supported sensors from different suppliers for different applications because they are serving different application domains. Another requirement was that the wet-dry interface, so the interface between the piece that's under the water and the piece above the water, shall accommodate a wet end simulator, obviously for testing and validation purposes. So here are the challenges that they were running into. A common interface that supports all variability requirements, they found that it was not possible because of lack of cooperation due to conflicting strategic requirements from the various suppliers. We find that in many industries. And also, the internal engineers had to build specialized interfaces for every combination of components, which defeats the purpose of having a single base model to work off. Here we're showing a couple of diagrams to illustrate those variability requirements. This is an excerpt from their domain model. You have the sonar that consists of a transmitter and a receiver. And each one of those has a receiver array or transmitter array. And the bottom side is looking at the deployment diagram, or component diagram rather, that shows variants from different suppliers for the transmitters and for the receivers. And again, the challenge here is to accommodate all of these different combinations without having a proliferation of models and specs and artifacts. So We're going to look at some common model-based solutions for specifying variability. These are different solutions, different approaches that we have encountered throughout the years, and I'm going to make a commentary about each one of them. But we're specifically looking here at the configuration management mechanism that various people have used throughout all this time. And I gave some of them somewhat silly names to reflect their salient pitfalls. The first one is what I call the Mangler approach. For those of you not familiar with the word, the Mangler is somebody who mangles things and messes them up and shred them to pieces and so on. The Mangler uses language constructs. Here, I think I have a slide for that, right? It uses language constructs within the system model itself to include things like version, configuration, and product family specific information inside the system model. Now, I'm sure you don't need me to tell you that this is bad because we are intermingling concerns over here. So use this approach if you want a short-lived and unmaintainable base model. And in this example that we're looking at over here, we are taking each one of the major components or subsystems of the sonar system, and we are using a specialization hierarchy to address each one of the different application domains. So this violates the principles of separation of concerns, and this information simply does not belong in a system model. The next approach that we have seen to address configuration management requirements is what's called the branch approach. The branch approach, this is where you use a modeling tool's version controls. Some of them have it integrated with the modeling tool. Some of them have on-the-side version control system with branching capability. And we use branches to define a specific configuration. This turns out to be a common solution that organizations use, but its downside is that it produces a proliferation of copies of the system model. So when you make common updates like bug fixes, it becomes super costly because a change now must be propagated to all branches. The next approach is what I'm calling the proliferator approach. The proliferator is where we define a new product variant, and by having modelers take a copy of the system model from an initial reference model and customize these copies per customer or per product line or per domain. So here we have the same problem as before, like the branch approach, because you end up with a proliferation of different copies of the system. Finally, we have the single base model approach. The single base model approach, this will be the approach of choice because it sets the stage properly for the main challenge of product family engineering. It embodies a strategy for specifying, maintaining, and deploying product variants across varied markets from a single base model and reusable parts like reusable components, reusable architectures, and so on. Now, this approach requires an advanced model-based practice where practitioners know how to define domain-specific languages. In this case, the domains we're talking about are the configuration management domain and the product family engineering domain. We surely don't have enough time to go over all the details of this, so I'm going to share with you the highlights of this approach. And I have to prepare you. It's a fairly unusual, but it's a proven approach. And we have been offering training for a while on how to build this capability into your MBSE environment. And we have a course coming up in July that packages everything you need to know to fulfill this capability in your environment. To understand the base model approach to configuration management, and after that to product family engineering, we must first understand the model-driven architecture anatomy. MDA, for those of you not familiar, MDA is the model-driven standard, that is a model-based environment equipped with model transformation capabilities based on formal meta-models that specify a cascade of levels of abstractions, as you can see illustrated in this figure, starting from business level or engineering level specifications and generating intermediate models all the way down to the final executable system or application. So the idea here is not to establish a full-blown MDA environment. That's a whole effort on its own. But the idea here is to understand the MDA anatomy itself and work according to its principles. Now, there's a lot going on over here, but I'm simply going to share with you the two main principles of model-driven architecture. First, we have the principle of separation of concerns across different levels of abstraction. So in the figure over here, you see on the left, the yellow section here, that is the system or business application model. This is where a model expresses, the business requirements or things at a high level that is non-technical, non-executable. And from there on, we go through a refinement process, which involves generating models from higher level models to lead to multiple levels of intermediate abstract models. And these are shown here as PIM1 and PIM2 and so on. And finally, we get to a concrete model, which is referred to as the platform-specific model. A platform-specific model means it's a model that now is tied to a specific infrastructure or middleware, whatever the case may be, right? So compared to conventional development thinking, that would be like the design level model, right? It has far more details. It has all the details needed to generate code from it. And finally, from that, we get the runtime context. You have a machine executable, and that would be the computing domain. So this is the general anatomy of model-driven architecture. So again, the first principle is the separation of concerns across these levels that I just shared with you. The second principle is the ability to model the various stages of product development according to formally defined and clearly confined abstract platforms, and these would be those PIM1 and PIM2 levels. So the base model approach looks something like this. You start by defining your product features, and when we're not talking about requirements here, we're talking about the features that will show up in a given product for a given customer in a given application domain. And we'll call that the configuration, so that's configuration management. And from that, we will generate the actual product configuration that's defined according to a platform-independent model, right? So here's, we're showing an instance of that MDA anatomy, but specifically focusing on configuration management. And from there, we generate a product-specific model, which contains all the data, or the metadata rather, of what the product configuration consists of. What are the characteristics of the single base model approach? First, we must keep the product configuration and variant metadata completely out of the system model. We don't want to mix these two at all, for the reasons that we have mentioned earlier. Second, we must rely on configuration management and product family engineering languages defined with a formal meta model. And I'm going to show you an expert of what that looks like. So just like you define a domain-specific language, that's what we're doing over here. And finally, that the meta model conforms to the Meta Object Facility versioning and development lifecycle specification. You'll find this on the Object Management Group website. For those of you who are not familiar with the Object Management Group, OMG, they have literally tons of specifications that have been developed throughout the last 2 decades that solves all sorts of problems, and this is one of them. So this is an excerpt from the MOF VDLS, and I'm simply sharing that with you here to show you how they have already solved the problem at the language level. MOF stands for Meta Object Facility. That's part of this is the basis. Again, for those of you not familiar, it's the basis for all of these languages that you use, UML, SysML, and so on. The whole idea here is to have a formal language that you're going to use to specify the configuration management from a single base model approach. Finally, there are a specific set of tool requirements to make that single base model approach a reality. The requirements are that you need an enterprise-grade modeling tool that is capable of model generation by way of formal model transformations. Now, I think most of the known enterprise-grade modeling tools have this capability, right? We use Enterprise Architect from Spark Systems a lot, and Enterprise Architect does have transformation capability. But of course, for those of you who use other tools such as Nomagic, Cameo, and so on, they also have transformation capabilities using the Query View Transform QVT language, which is also a very powerful language to have available to you when doing product family engineering and configuration management for a single base model. So the first requirement is a modeling tool that has model generation or transformation capabilities. Now, the second requirement is that you need a visual diff and merge tool to inspect, verify, and validate the generated models. Right? That's very important because when you generate models, you really cannot 100% rely that your transformations were correct. So there is a certain level of verification and validation required. But the good news is that usually you do these only a few times until you prove your transformations. And most importantly, that visual diff and merge tool must have the ability to merge various parts of the model towards a finalized system model. Which brings us to LemonTree. Daniel, would you take a few minutes and tell us about LemonTree? I'm going to roll the slides for you at my end.
Okay, no problem. No problem. Welcome again to everybody. So LemonTree was developed basically to solve something that is surprisingly not solved by other companies in the same way we do it, that you need a reliable diff and merge capabilities to be able to work with models in safety critical systems. But also, as it happens now, banks and other domains start to use it because they see also the value in it. What LemonTree is beyond compare or WinMerge for enterprise architect models. One of the key drivers why our customers use it, maybe you can go to the next slide, is that LemonTree, or a process where you store your model in a configuration management in a sustainable way, is required for most safety critical norms. The IEC 61508 is one of the master norms, but also the ISO 2622 from the automotive context. And as you can see, this is what our customers tell us. It's not our opinion. Next slide, please. Here is some of the hints from the norms that lead our customers to believe they need to manage the model in a professional way in a version control system. And you can version with Enterprise Architect and the built-in functionality with a version control system like Subversion or SVN, as we call it, where you can do a pessimistic approach. Pessimistic means whenever you want to modify something, you need to gain an exclusive lock on the part of the model you want to modify. Then you modify it and return the lock back. But this is not necessarily how you can survive agile projects if only one guy can work on one aspect at a time. So what people need really is optimistic version control, as shown in the chart here, where both people can work on the model. And if I check in, or Philip in this case checks in after myself, there is a conflict, which is not necessarily something bad. It just means we need to merge the changes together. And this is the unique capability that LemonTree brings to modeling, that you can work in this way. Next one, please. This sounds nice, but you might think, oh, we can work pessimistic, no problem. But the optimistic also gives you the additional benefit that you can now use branching. In this chart, it shows branching for a platform and customer projects. But what is also very common, or almost the best practice how to use LemonTree, is that people do feature branch-based development also in MBSE. So a process like Git flow that you would expect to be executed in software engineering now also is widely used in MBSE, because finally you can do it. And one of the key benefits of this work style where you're not shy of creating branches and not shy of merging branches is that you can support people who are less experienced in a very good way. Every time you see the LemonTree symbol is a good time to look at changes other people did, talk to them, help them improve their modeling work. So it's not just making it more fancy, it's also much easier to get people on board and keep people motivated. Next one, please. Here's some of the highlights. As we said, diff merge, yes, model versioning. I think this was covered. We have tight integration with version control systems. And I think it needs to be stressed that the combination of Enterprise Architect and LemonTree is at the moment the only commercial UML, SysML modeling tool that has these capabilities to have a graphical merge that can be used with Git in a proper way. Branching is a side effect, but it's super helpful. Ernest, it's you again.
Thank you, Daniel. Appreciate this. And I'm looking at the time. We do have time for a demo. So what I'm going to do is launch LemonTree so that you can see what it looks like and what it's capable of instead of us just talking about it. So if you give me a moment to switch to my screen share to the tool. And here I've selected 2 sample projects that come with the tool to demonstrate. So in that first dialog, it asks you whether you want to do a 2-way or a 3-way comparison. So I'm going to keep it simple here. And Daniel, by the way, if you want to jump in at any time, please go ahead. And I'm going to click on compare. These all come from the same base model, but they have some differences. Over here, we see the first version that we're calling A.EAP and the B version that we call B.EAP. And here it's telling us that there are a certain number of differences between the two. So I'm going to expand and navigate to a specific difference. Under this item, we have a class, we have an activity under it called transmit, and under the activity, we have an activity diagram. And in this activity diagram, if you look a little bit lower, now it's showing us the actual diagram, and the tool is showing us the actual difference. In the one on the left, A.EAP, the activity has 2 actions and some other nodes. And on the one on the right, B.EAP, we have removed one of the actions and left with only one, and we added a node. If you look further down, you have an element properties that's showing you exactly what has changed between the two, what properties. And I don't think that's in here, but even if you have changes in your meta level information like profiles, then it will show you that differences, the tagged values and so on. So now that we see these 2 differences visually, by the way, I've been doing this for about 25 years, and this is the very first visual diff and merge tool that I've found on the market. Before that, we had to do it the hard way using XMI or just looking at documents. So
you would not expect which big companies create PDF documents from models and compare the PDFs, which is obviously a very inefficient way to get the job done. And you never could have this detail like here in the diagram that you really see what has been altered in the diagram.
So I'm going to move to merge mode. So now we have the 2 base models, and on the far right, we have a preview of the merge. Once you inspect everything and you're satisfied with the change, then you click on Start Merge. It's going to prompt me for a spot to place the merge. I'm going to simply keep it called merge.eap. And now the writing is complete. Open the merge file. It launched Enterprise Architect for us.
Ernest, we have 2 questions that I would want to take right now.
Go ahead as I find my way on the screen.
So From Florian Schellenberg, we have the question, does LemonTree also work when having the model in a Siegl database? Florian, yes, the diffing is possible with the standard license since LemonTree 3. If you want to also have a merge way of doing it, I would like you to contact us to discuss all the details. A typical use case is that people model with Git, but publish the model to a centralized database so a wider audience in their organization can use the model. But Florian, as I said, if you want to, we can discuss this in private later. It's a longer topic. And Aditya asked where to find the slides used for the demo. I think Ernest and I will publish them on the LieberLieber blog and on the Achilles blog after early next week, I guess.
We'll do that, and we'll also share we're recording this presentation, so we'll also share the video. We'll post it on YouTube. Thank you for the questions, and please go ahead and ask more questions. Your options are the chat box or the questions and answers box that you can find from the Zoom control panel. So here we're looking at Enterprise Architect, and we're looking at that one diagram that we're looking at in LemonTree, and we see that that's the merged version, and we see that we have the removed action and the added note. So with that, I'm going to switch back to the main presentation to finalize. So where to go next? For those of you interested in LemonTree, please contact LieberLieber directly, like Daniel said. Here is all the information and some of the prerequisites for using LieberLieber. Daniel, you guys offer a trial version, correct?
Yes, you can simply download it and start using it.
Fantastic. So with that, we're nearing the end of the webinar. Again, we're open for questions that you might have. The third webinar in the series, and that will be the product family engineering in model-based systems engineering environments. It is tentatively scheduled for Wednesday, June 16. And in that webinar, I'm going to go even deeper into the things that we talked about and talk about how you can establish a product family engineering platform using your standard model-based system engineering environment. And that completes the webinar. Questions?
One more question about the pricing of LemonTree. This depends if it's US dollars or euros, and roughly a bit over 2,000 in both currencies for 1 year. And the floating seat typically is enough for 3 to 5 enterprise architect modelers. If you want details, Luis, please write us an email at welcome@LieberLieber and tell us where you're at, and we will send you the exact price. Which version control is better for enterprise architect with LemonTree, SVN, or Git? I would say Git, because you have a wider support for modern agile work style. You can do most of the stuff also with SVN, but simply for Git, you have better support for stuff like workflows or feature-based branched working. But we also have customers using PTC Integrity Lifecycle Manager and work in a Git flow style way. So it really doesn't matter so much, but the best practice is Git. So we have a comment from Diogo. Just started using LemonTree and Git flow, and it's awesome. It really helps to solve some AR issues, such as baselines. And also for certifiable projects. So I think this is a very good feedback, and we like to hear this, and we keep pushing every day to make this better and better. Does LemonTree work with Magic Draw? Interesting question. No, it does not, is my answer.
All right. Thank you all for attending. Daniel, thank you for the superb support. Usually I get nervous if I know that you're not going to show up. Well, everyone, have a great day or great evening, depending where you're at around the globe. And I will see you on the third webinar in about 3 weeks. Take care, everyone.
Bye-bye.
Bye-bye.